Hello everyone, I am Chetan Rajoria from the Department of Mechanical Engineering, ABES Engineering College, Ghaziabad. I welcome you all once again to this video lecture series. In this lecture today, we are going to take another problem based on engineering mechanics. And today's topic is the problem based on a static equilibrium of inextensible string system. We are going to take two problems based on the same topic, and this is the first problem. So let's start. So students, this is the problem. A string is subjected to the force is 2 kilonewton and P kilonewton as shown in the figure. As you can see here, this is the string system AB, BC and CD. This is an inextensible string, okay? The length of this string cannot be extended. The length is fixed, okay? And these type of strings can be used for tensile forces only. These strings cannot be used for compressive forces and are only applicable in case of tensile loading. So this is the force system as shown in the figure. A 2 kilonewton force is acting on this junction B, and P kilonewton, the amount of force P is unknown, and this P kilonewton force is acting on this junction C. As usual, the weights act vertically downwards. So this is acting vertically downward 2 kilonewton, and this force is also P kilonewton. The question is, we need to determine the magnitude of P and tension in the various portions of the string. We need to calculate what is the value of the force in this string portion AB, the string portion BC, and the string portion CD. We need to calculate the forces which are being transferred into these three string systems. So how to proceed? Please observe this part. On this junction B, we have a known force 2 kilonewton. And if we consider this junction for free body diagrams, we will definitely going to have two unknown forces, TAB, the tension which is being transferred into this string segment AB, and TBC, the tension which is being transferred into this string segment BC. Instead of this junction, if we consider suppose junction C, in that case, we are going to have three unknown forces, TBC, TCD, and and this unknown force P. So instead of considering this junction first, we need to consider this junction first of all, because in that case, there will be only two forces which are unknown, TAB and TBC. And these two forces can be calculated very easily using equilibrium conditions. So let's consider, we are going to draw a free body diagram of this junction B. So I'm going to draw a separate diagram for this junction B. Suppose this is the junction B. This is the string BC. So the force which is being transferred in this direction is TBC. This is basically the reactive force or reaction force, because the tensile force is acting in this direction like this. The actual tensile force goes like this, but we are going to show the reactive force in the opposite direction. So this is the reactive force TBC. Now, this is the known force. The magnitude is 2 kilonewton. And the third force is TAB. And these two angles are given. This angle is 30 degrees. And this angle with horizontal is 45 degrees. These two angles are already given in the question. So how to proceed? First of all, we can clearly observe that this is a simple case of a Lami's theorem. We can easily apply Lami's theorem for the calculation of TAB and TBC. But before applying Lami's theorem, we need to find out the intermediate angles. So let's consider these angles first. The value of this angle, the angle between TAB and TBC, this value, this will be equal to 180 minus 45 minus 30 degrees. And this will be equal to 105 degrees. Okay, which is equal to 180 minus 45 minus 30. Similarly, the angle between TAB and 2 kilonewton, this angle, this will be equal to 90 plus 45 degree, which is equal to 135 degrees. And now the angle between TBC and 2 kilonewton, this angle will be equal to 90 plus 30 degrees, which is equal to 120 degrees. Now we have calculated these intermediate angles. We can easily calculate these two forces using Lami's theorem. So let's apply Lami's theorem once again. So the statement of Lami's theorem will be TAB upon sine 120 degrees is equal to TBC upon sine 135 degrees is equal to 2 upon sine 105 degrees. So according to Lami's theorem, the ratio of any force, if in case of a 3-force system and the force system is under equilibrium, in case of planar force system, in that case, the ratio of the force and the sine of the angle between the other two forces, this ratio remains constant. So I have used this theorem for the calculation of these two forces. If we consider the first and the third term, we can calculate the value of TAB. So TAB will be equal to 2 sine 120 degrees upon sine 105 degrees. If we calculate this using our calculators, the value is coming to be 1.793 kilonewton. This is the first answer. Similarly, if we consider the second and the third term, we can calculate the value of TBC. TBC will be equal to 2 sine 135 upon sine 105 degrees. By calculation, this value is coming to be 1.464 kilonewton. So this is the second answer. So out of these three, you can say these three forces which are being transferred into these strings, we have already calculated the values of the string in AB and the forces in string BC. Now we will consider the free body diagram of the second junction, junction C. So I'm going to draw the free body diagram of the junction C. So this is the junction C. This force is TCD. This force is TBC. And this is the vertically downward force. Vertically downward force P. This angle is 60 degrees. This angle is 60 degrees given in the diagram. And once again, we are going to apply Lami's theorem because TBC is known now and we can calculate the value of TCD and this unknown force P. But we need to calculate the intermediate angles first. So how to calculate this angle? The angle between TBC and TCD, we can calculate it very easily. Let us see how to calculate. So if we increase this part, suppose this dotted line, if we are going to increase that part, or you can say producing this part in the back side, so this angle becomes 30 degrees. This portion is 30 degrees. 90 minus 60, that is 30 degrees. And this straight line indicates 180 degrees angle. So if this angle is 60, so this portion of this angle, this obtuse angle, this angle will be 180 minus 60. 180 minus 60, that is 120 degrees. And the total angle between TBC and TCD will be 120 plus 30, that is 150 degrees. So this complete angle becomes 150 degrees. Now the angle between TCD and P. Angle between TCD and P will be equal to 90 plus 60. 90 plus 60, that is 150 degrees once again. And the angle between TBC and P is already given, it is 60 degrees. So now we have the intermediate angles between these forces. We can calculate the unknown forces using Lami's theorem. So let's apply TCD upon sine 60 degree. TCD upon sine 60 is equal to TBC upon sine 150 degrees is equal to P upon sine 150 degrees. So remember, TBC is known. Okay, this is not unknown, this is known value. Now, if we consider first two terms, we can calculate the value of TCD. TCD will be equal to TBC. The value of TBC was 1.464 kilonewtons. 1.464 kilonewton. 1.464 kilonewton multiplied by sine 60 degrees upon sine 150 degrees. So value of TCD is coming to be 2.536. 2.536 kilonewtons. This is our third answer. Now, if we consider the second and the third term, we can calculate the value of P. P is equal to 1.464, which is the value of TBC, multiplied by sine 150 upon sine 150. So sine 150 and sine 150 cancelled out. So value is 1.464 kilonewton. So the value of this unknown force is 1.464 kilonewton. So these are our third and fourth answers respectively. So in this way, this problem has been solved. We have calculated the value of the individual forces which are being transferred into these three string segments AB, BC and CD, as well as we have also calculated the value of this unknown force P, which is acting vertically downward at point C. So that's all for this problem. Okay, thank you so much.